The important part of object-oriented programming is not the objects themselves, but the messages that go between them. And the way that you change the behavior of a system is by composing objects. Let me give you a contrived and yet concrete example. Imagine that you have two objects here. You have a ticket machine interface and a ticket reserve system. So maybe imagine that the ticket machine interface is hooked up to some request coming in to Rails. I would assume that most of you are probably working in a Rails context. And the ticket reserve system is some external service, right? It's going to receive requests coming in from the browser saying this number was pressed, or delete was pressed, or submit was pressed. And it's going to collect that data for the numbers, like, you imagine, you push 5, you push 5, you push 5, you push back, you push submit request. What's going to happen? It should send a message to the ticket reserve system saying, reserve 55 tickets. Because I pushed 5, and then I pushed 5 3 times, and then I pushed back once. So the idea there is it's going to send the message to the ticket reserve system. Now imagine you have this system, and imagine you want to save the requests before sending them to the API. How would you do that? Well, if you were doing a procedural programming approach, you would go into the code of the ticket machine interface, and before you talk to the ticket reserve system, you would add code to first save that request before it sends it. But in a OO programming way, what you would do is you would change the object composition. You would add another object which would be responsible for persisting that data. So maybe it would look like this. From my ticket machine interface, when it says to reserve the tickets, it first sends a message to the persist ticket requests object, and then when that succeeds, it sends a message to the ticket reserve system. You see the difference? It's not opening back up another object, it's changing the composition of those objects in order to accomplish the same thing. This is generally one of the, so how many of you have heard of the open-close principle? Right, it's one of the solid principles. It says objects should be, what?
Open for extension.
Open for extension and closed for modification, right? The idea is you can extend an object, but you're not going to modify the behavior. You would be modifying the behavior there, and you would be introducing another responsibility into the ticket machine interface if you were to just put that code directly into the ticket machine interface. And so in OO, the way you would want to do that is you would want to add another object that its sole responsibility was doing that persistence. So let's zoom in and look at this ticket machine interface for a sec. What would the code for an interface like that for the ticket machine interface look like? It might look something like this. Because you'll notice all of the arrows are flowing right. There's no reading, there's no asking for information here. There is only telling other objects to do something. And so the code would probably look something like this. You would instantiate the ticket machine interface with a request handler, and then when a number is pressed, you would keep track of that, whatever the current display is. When delete is pressed, you would back it off one. And when submit request happens, you would send a request handler, the reserve message with whatever the current display is. And I want you to notice two things about this code. First, it follows the tell don't ask principle. That is, it tells the object that the number was pressed, it tells it that delete was pressed, it tells it that submit request was pressed. It never asks for any information out of the object. Second, it hides its internal state. Notice, current display is not exposed anywhere outside of this object. In fact, I might change the way that I store current display. Maybe instead of storing it as a string, I want to store it as an integer as I go along. I could do that without breaking any other code anywhere else, because all of the objects outside of this object have no idea that current display even exists. It's hidden inside of the object. This is kind of OO sort of related code. Now, if you come to this, how can you assert on state? If I wanted to test that this object did the right thing, how would I do that? What state would I assert on? Well, the only thing I could do is I could add getters to this object to get that current display information if I wanted to test it. And I would have to be adding those getters only for the purposes of testing. I would not actually be using those getters anywhere in production code, which I would argue is a very bad idea. And so this is where the idea of mock objects originated. You have people who are wanting to practice good, solid, object-oriented design, following the tell, don't ask principle, and yet they also, being a part of the XP community, are going, I want to be able to test this. But it feels wrong to put getters on this object just to be able to test it. So how would I test it? Well, remember what Alan Kay said. He said object-oriented programming is all about what?
Messages.
Messages. See, I don't really care about what the state of this object is when I'm doing OO. All I care about is the message going between the object. And in this case, it would be sufficient if I could just assert on this message. If when I said number pressed 5, and then I press submit request, what should happen? A reserved tickets message should be sent with the integer 55 passed, right? And if I could assert on that message, I could respect the encapsulation of my ticket machine object without having to, introduce things onto the object to specifically change it. And so how could I do that? Well, what if I were to replace this ticket reserve system with a fake object? And this fake object's responsibility is only to keep track of the messages that it is sent so that I can then query which messages were sent to you and do an assertion on it. And that's essentially what a mock object actually is. It's saying, I want to assert on this message going between two objects, and I'm going to have a nice little domain-specific language to specify how to do that. And I'm going to create a fake object to do it. And so in RSpec, you would write this something like this. You would describe the ticket machine interface. You would say it reserves the number of tickets inputted when the user submits a request. Right? And the first thing you would do is you would create a mock object, which in RSpec is called a test double. The language there is coming from XUnit test patterns, and I'm not even going to try that name of the author there. But basically, the idea is the industry is kind of standardized, saying you have multiple types of fake objects. You have a mock object, you have a stub object, you might also have a spy object, and if you work with Jasmine, right? And those are all types of what we call test doubles. And so RSpec says this is a test double with the type request handler. Okay? And that is equivalent to this object. I'm inserting the fake object. And then I'm going to set up this assertion. Should receive reserve with 55. All I'm doing is I'm setting the expectation on that mock object. That's setting an assertion on this message going between the two. And then I fire off the behavior that would happen in the system. Number pressed 5, submit request. And if the object sent reserve with 55, it would pass. And if it didn't, then it would fail. It's a pretty simple idea once you get it, right? So, but the key idea here as to why mock objects exist is that in object-oriented programming, behavior is found in the messages, right? This is part of the reason why a lot of the people who created BDD are also very mock-heavy originally in their testing, because they're saying they want to test behavior. And by that, they mean, I want to test the messages going between objects. And mocks assert on messages. That's all a mock is. Okay, so assuming now you kind of go, okay, I get that. Why is it then that my mocking tends to create brittle code? It's because you're not following a couple key mocking rules. And I'm pulling these directly from what has been said by Steve Freeman, largely, over the past 10 or 15 years, right? There are a couple key mocking rules that when you are doing mock-heavy TDD, you want to follow. And the first is you want to mock roles, not objects. If you're interested, this is a paper that was submitted to Uppsala in 2004 called Mock Roles, Not Objects. The key idea here is that wanting to mock a concrete object is a design smell. That is, if I'm writing a test for my ticket machine interface, I shouldn't know what object it is talking to. Because well-designed objects don't know who they're talking to. Well-designed objects are decoupled from their surroundings. They only know the interface that they are talking to, not the concrete implementation that it's talking to. Why? Because who they are talking to can change. They should only know the role that the collaborating object is playing. So for example, if we go back to our concrete ticket machine interface here, if I'm writing a test for my ticket machine interface, I should not hang a dependency on the fact that it's talking to a ticket reserve system. Because I might say, want to change that ticket reserve system to a persist request object, right? I'm going to change the composition. And so what I want to do is I want to say, what is the role that this object is talking to? And the role here is the ticket machine request handler. And at this point, the ticket reserve system is playing the role of the ticket machine request handler, but as I change the composition, now a persist ticket requests object might be playing the role of the ticket machine request handler. The key thing to note here is that when you're mocking roles, TDD becomes a design process. Right? So I come back here, I don't know that the persist ticket request or the ticket reserve system exists yet. I'm gonna write those after I do the ticket machine interface. All I'm asking is, what dependency does this ticket machine interface need in the general? What is it that it needs to talk to in order to do its job? And it needs something to handle these requests. It doesn't need to care how it handles the requests. It just needs an object that is going to handle the request. And so when I'm mocking the roles, TDD becomes a design process. It says, okay, how can I decouple this object from its surrounding neighbors? And so I would start with this interface. Presumably something is talking to this object, right? And so it has number pressed, delete pressed, submit request. And the first thing I'm going to do is I'm going to write a test like this. I'm going to say it reserves the correct number of tickets when a number is pressed 2 times before submitting. And I'm going to write out how I would do that, how I would use this object. Machine equals ticket machine interface new. I'm going to tell it that 5 was pressed, then 5 was pressed, and submit request was pressed. And then I want to describe the behavior of that object when this sequence of events happens. And the behavior that I would expect is, I would expect whatever object is playing the role of request handler to receive a message with the number 55. So I'd write this, I'd go, okay, this is my test, this is a dependency, I cannot actually do my job as a ticket machine interface unless I have a request handler, so I'm going to pass that request handler into the constructor, and then I'm going to run my test. And it's going to say, request handler did not receive message 55. And so I'm going to do, something like this. And I probably would start out not doing this. I would probably just do request handler reserve 55. If you've done TDD, this is kind of the stupid, we know this is not how it's going to stay, but then it's going to, right? And then I would probably, okay, it passed, it sent reserve 55. And then I would refactor it to do something like this. Current display starts with a string, add to the current display the number of the string, right? And then pass it the 2i version of it. And then the next thing I would do is I would go write another test. I would say, okay, what if I pushed number pressed 3 times and then pushed delete pressed? Then it should receive the message, reserve with 55 again. And then I would implement the delete pressed, etc. The key thing to take away there is you mock the role, not the object. You want to think about this object in isolation from its collaborators, and you only want to say what roles are these potential objects that I'm going to have to collaborate going to play. That way I can switch the actual implementation of what those objects are to change the behavior of the system. Okay, second rule. Only mock types you own. This is from a paper, again, I think this was submitted to UPSLA. Yeah, actually this is in the same paper as mock roles, not objects. So you can look that up. The key thing to note here is that when you're using mock objects, if you don't own the API, and by that I mean you did not write the object, you are not going to change the object, then there is no design feedback that you are going to get by using a mock object, right? Notice how as I was describing that last process, the whole thing that I was doing was design. It was decoupling as I was writing the test, right? If you don't own that external API, you can't say it should receive this message in my terms. All you can do is give it a concrete implementation. And so instead of mocking a role, you end up mocking a implementation and couple your code directly to this external API. It's probably fine, right? And you end up duplicating your production code in your test. So, for example, the David Chalimsky RSpec one, you had output.puts, right? The message that was being sent to the output generator was the message of the I/O object. And so you end up having the exact same implementation in your production code and in your test code. And I think we should all agree, just duplicating your production code in your tests is always a test smell. Always. But this does mean you don't mock boundary objects. So like, for example, here, output put should receive puts. And this is just going to be standard Ruby I/O and then output.puts. So what should we do instead? And David actually wanted to change this in the book, just where you know. You want to mock the role in the domain object. And so in this case, you have a game, right? And what you really want to say is you want to say, whoever is responsible for doing the display of this game, it should receive, and I would say, you know, probably display title, I just didn't have space on the slide, should display the title, Welcome to Codebreaker. And then the same thing here. And then you would implement the display object using puts. Now, how is this any better? Isn't this just kind of pushing it out one sense? The idea here is that you actually have a role in your application of displaying that right now is being fulfilled by the command line, right? But it is very possible in the future that role might be fulfilled by a graphical user interface, or that role might be fulfilled by Rails. And the idea is you want to decouple the logic of the startup from the logic of the display. And so that's what you would do. You would say it should send this message to some object responsible for the display. Now, what about testing the display object? That's what integration tests and acceptance tests are for. You don't generally want to mock out a concrete object that you don't own. You want to test that with the whole of your system. Okay, last point. This is developed a bit more recently. I don't think there's been any papers submitted on it. It's existed for, the idea has existed for a long time, but the formulation has only been stated more recently, probably the last 4 years or so. You only mock peers, not internals. Here's an example of where you can find the idea. The idea is when you're writing a test, you have to decide what the encapsulation of your object is, right? Where are you going to draw the barrier of encapsulation around the object that you're testing? You have to decide what goes inside the object and what goes outside. Everything that goes inside is an implementation detail that you might change, right? And you don't want to couple a test to an implementation detail. Everything that goes outside is a role that another collaborating object is going to play, right? And not everything belongs to a peer. And the key question you want to ask in doing this is, what is the role that this object that I'm testing is playing? Does whatever I want to do in this other object, because it's more convenient to me to have another object, does it fit inside of my role, or is it actually doing something else? This comes down to the single responsibility principle. An object should have one and only one reason to change. If the object that you're wanting to create, wanting to build into existence, is going to change for the same reason as the object that you're testing, keep it internal to your object. If it's going to change for a different reason, it is a collaborator or a peer. And that is something that you can mock and send an expectation to. So here's an example. This is from the Growing Object-Oriented Software Guided by Tests book, where they're building an auction system. And you have an auction server that sends a message into the application in text, right? And then they have an auction message translator. And different types of messages come in, and then the translator is going to translate them into the language of the domain instead of the language of the server. And a test looks something like this. It notifies the bid details when the current price message is received. So for example, it has an event listener, and the listener should receive current price with 192 and 7. I'll explain that in a second. The translator gets created, a new message happens, and here is the body that is being sent from the server. SOL version equals 1.1. Event price. Current price 192. Increment 7. Bidder someone else. This is the string that's coming down from the server, and then we're going to say, translator, process this message. And what we want is it's going to translate what this message means into the domain of the application, which means this is actually updating what the current price is, right? And so it's saying the current price should be 192 with an increment of 7. That's simple behavior. But when they come to write the actual implementation, they do this. They say, okay, when I process the message, I'm going to create an event, unpack the event from the message. If the event type is closed, the listener should send auction closed. If it's not closed, the listener should send current price with the current price of the event and the event's increment. Key thing to notice here is in unpack event, they have another object, this auction message event, which they're passing the message into, and then they're using it back up here. Event type.close and event.currentPrice and event.increment. Right? And so this is another object. Should we mock this other object? Should we stub this other object? Is this something that is helpful to do in our testing? No, it's an internal object, right? It is something that strictly is an implementation detail of how we're currently implementing the auction message translator. We want to draw the barrier of encapsulation outside of that object. Anybody who's going to use the auction message translator should not need to know that auction message event even exists. All it needs to know is the interface that it can send the messages to and the events that potentially come out of it. And so it's an internal object. We don't want to mock it. We don't want to stub it. Why? Because it's an implementation detail. If we change the implementation, this object is going to change. And so anything that is inside of that barrier of encapsulation, we want to respect that object's encapsulation and not reach in and change it. Okay, a couple further resources. I think actually there's only one. Growing Object-Oriented Software, Guided by Tests, Steve Freeman and Nat Price. If you want to understand mock objects, it is helpful to go to the people who came up with mock objects and say, okay, how did you intend them to be used? And that's what this book is basically all about.
Is that book kept somewhat current, or is it is it revised?
I'm not sure if it's been revised. I don't think so. But they have a discussion group. They have a Google Groups discussion that is still fairly active. There's probably, I don't know, somewhere between 5 and 10 posts to the group every week. And people are continually discovering it and discussing it, and so on and so forth. Any other questions?
Is that me?
Yeah.
How do you deal with changes in the contracts between objects?
Sure. So the question was, how do you deal with the changes in the contracts between objects? You mean like refactoring an interface?
Yeah, like let's say you come onto a project and you want to change the contract because it's more verbose than you want it to be or something like that.
So I think that's the sort of case where you're changing the behavior of the objects, which means you probably should be changing the tests. Generally, what I've found is when things are architected in a more OO sort of way, and you want to change the interface, the thing that I find myself doing more commonly is the object with the interface that I want to change, I will replace that object with a new object that implements the interface coming in and a different interface going out. So that I don't have to change the behavior of the parts of the system that I'm not changing. I will just swap that object and generally throw away the old object and its unit tests.
Okay.
But if you want to do it in the same object, you would just have to change the tests.
Can I just add to that? I actually have an example from the practical object-oriented Ruby by Sandy Metz, and that book actually addresses that particular thing. How do you keep the marks in sync with your actual real objects?
In particular, I'd be worried about code breaking and not knowing because the mocks...
It's talking about the false positive, false negative, those kind of situations.
Well, the mocks will cause your tests to pass because they conform to the old interface.
Sure. And I think that the primary thing that I'm helped by in mocks in that sort of situation is that this really is a design change, right? And I want to think about it in terms of design terms. And I do find, though, that if you are decoupling your objects, it's easy to actually swap the object as opposed to actually like having to go in and change existing code.
Right.
But that also is part of the reason why, if you ever notice, Cucumber and acceptance testing developed in the BDD community, which is also very mock-heavy, right? Part of the reason why the end-to-end sort of tests became important is because now you're testing every object in isolation. And so you want to know both that every object works in isolation and that all of the objects work together.
Yeah, I know JB Rainsberger has some thoughts on like contract tests too and things like that.
JB's on the growing object-oriented software list all the time too.
Cool. Yeah, JB's contract test. Sandy Metz has an example on it.
Well, he hates integration tests, so I was just curious what you thought.
So he hates integration tests, but he is not bothered by end-to-end acceptance tests. So as I understand JB's argument there, there's a difference between an integration test historically and an acceptance test. An acceptance test is you're treating the entire system as a black box, poking at it from the outside. And an integration test is you're taking multiple components, some subset of the system, and running a test against multiple components. And JB's argument is basically, if I understand him correctly, this is actually a scam. Because if you actually need those integration tests where you're testing those components together, if it is going to catch a regression, there is something wrong with your unit tests. And so he's saying, like, it's a scam. It ends up taking longer and you don't actually get any benefit from it.
Actually, I saw his presentation, and to me it seemed like he was just stating the same thing from the growing object-oriented system. The authors were saying, you don't test all the different combinations at the integration level because of the explosion of number of tests. So he was saying, yes, you do need integration tests to prove the features exist, but at the same time, you don't want to have an exhaustive set of integration tests. To some extent, he was addressing the same points the authors were talking in that book.
Sure.
So I was mentally seeing if I got the presentation by trying to apply to different layers of Rails.
Sure.
And maybe part of the issue is given the architecture, there's a lot of room for design.
Yes.
So maybe it's not the right domain to be thinking about this. So I was starting with my models. I was like, let's start with the simple guys. And your first point was don't mock up things that you don't have control over.
Right.
That would mean active record.
Right.
So I guess my open-ended question is, how would I ground this in Rails? And I was sort of piecemealing it up the stack.
Sure.
I was curious if you
Sure.
a lot. What would you say?
So that's actually the most common question that I got after this talk. I probably got like 40 emails asking that specifically. How do I then connect using mock objects to Rails, right? And I think the first thing you have to say is that Rails has a very data-centric focus, right? Okay, active record is literally all of the database tables are getting extracted into a model object, which you're going to query for information and so on and so forth. It's inherently data-centric. And for systems like 37 signals, that actually is preferable, and you don't need like actual mock objects and a domain layer. When you're just dealing primarily with, I'm going to input this data on the web, and I need to persist it to my server, there's no real behavior there, and there's no need for a domain layer. The point at which you want to try to introduce these things is when you start moving to a system that is more focused on domain behavior as opposed to the data being stored. So I'll give you an example. I used to work for a moving and storage company. I wrote software for them in Ruby for probably 5 or 6 years. And when you schedule a move, there is a bunch of behavior that goes with that. There are a whole bunch of rules that have to be applied, right? And when I started working there, they literally just had data fields that they were filling out, and every processor had a little book. Processors, the people who answer the phone. They had a little book on their desk that when this sort of move would occur, they would turn to this page in the book, and then they would follow like a checklist of things to make sure that they create, destroy, modify, you know, etc. And that then becomes more behavior-centric. And when you have a more behavior-centric application, it makes sense to be able to do unit tests that those rules actually get applied, and so on and so forth. And so the way that you would generally want to do this is you would think of Rails as the borders of your application. How many of you have heard of the ports and adapters architecture? Right, so this is Alistair Cockburn. He says, you have, did I say? Coburn. See, I can't pronounce any last names tonight, can I? He says that, you know, you have your domain and you're going to talk to a bunch of external services potentially. The database to persist it, some display to display it, some place where the requests are coming in, etc. And you want to have an adapter that then talks into a series of objects that you have instantiated. You can do this with Rails, right? Rails really has two entrance, it has an entrance point and an exit point. It has a request coming in, right? And it has the view data going out. And so what you can do is you can introduce a domain layer that when the request comes in, it starts telling objects to do things, which then is going to percolate a series of events, which are probably going to talk to something to persist them, right?
Yeah, or like sending emails
or sending emails, exactly, right? It's going to do a whole bunch of things, and it's also going to talk to some object which is responsible for the presentation. And then, like, the first thing you have in your controller is it starts that event by sending a message to an object in the domain. After that has finished, it then goes to the next step, which is referencing that object in the domain, which is some form of presenter, which you then can reference in your views that contain the UI display. So there are two sources apart from like my little spiel there that I would encourage you to look at. The first would be domain-driven design by Eric Evans. He talks a lot about building a domain layer separate from the services. The other thing is if you go and watch Uncle Bob's Clean Coders episode. How many of you guys have heard of Clean Coders? You know who Uncle Bob is? Yes. Okay, Uncle Bob Martin does a series of videos. I think he's on like episode 9 now. And in his episode like 8 or 7 on architecture, he talks about how you want to think of Rails as the delivery mechanism. I think he got a good amount of heat in the Ruby community for giving that talk at Lone Star Ruby, something like that. And he goes through another potential architecture where he talks about things called interactors and something else. So that would be two sources in terms of how you can concretely implement this in a web context. Would be Eric Evans' Domain-Driven Design and Uncle Bob's episode on architecture.
Actually, can I plug in this book also? This addresses some of the things that he has been talking about. Object is designed by Rebecca Westbrook. And in XP, you use CRC cards for lightweight design. And this thing actually helps you to come up with this, the messaging between communication between different objects. And it also talking about different layers, like you were saying, domain services layer. I'll just pass this book around if you want to take a look. I think this is very helpful. That's a very old book. Yeah, it's a very old book. It's still like classic.
I think that's the newer one. She has an older one too.
I just got it today.
Is that the older one?
No,
she has an old. I think that's the newer one.
Yes.
Yeah, there's an older one too. Rebecca Wurst-Brock is actually the place where the idea of roles comes from. And that's a design term, not a testing term. She talks about the roles of the collaborators, and then the mock objects guys said, okay, apply that to tests.
This is a really mock sort of thing, but what's your general feelings about, you mentioned web services, for the amount and level of testing you should do for, like, if you have an SOA, and then with the larger, strict over larger systems?
Sure.
Should you do totally independent, or?
So I think the answer to that is almost always it depends. My general rule of thumb is for my acceptance tests, I want to get as close to end-to-end as I can. At the same time understanding that the pieces that my team does not own are generally very difficult to get into a sandbox environment. And so when my team does not own it, I generally end up writing a fake version of it to stub it in the acceptance test. Yeah. So I'll give you a concrete example.
If everybody stubs, then you don't really have the end-to-end.
Yes. And so you need some sort of integration between the two.
As long as the contracts are.
Yes. Yeah. So I'll give you an example. So last year I was consulting with eBay, helping them build the tablet web application, which is in the browser in JavaScript. And the team that was working on that was different than the back-end team building the middle tier for us. So we weren't consuming the eBay API directly. We had them build a middle tier in the data format that we wanted, essentially kind of having an adapter layer because it would be faster and more efficient to do JSON XML transforms in the case of eBay on the server as opposed to on the client. And so in order to write my end-to-end tests, I needed to talk to the server to get data, right? And so what I did is I built a fake server in JavaScript that I would sub in the place of my adapter. So on the borders of my application, any place that talked to the server would go through an adapter that would specify the message going to it in terms of the domain, and it would actually do the AJAX request, etc. And in my acceptance testing environment, I configured it such that instead of instantiating an object that actually talks to the server, it instantiates a fake object, like my fake server, that I registered URLs and expected parameters, so that when it would call the thing, it would do the fake server part. And then that same object, I configured to everywhere in my tests, it was saying it should be sending it to this URL, etc. Then I also had an API on that object that said run the tests, and it would actually hit the real API and do an assert that things actually came back in the format that all of my tests were actually expecting on. Yeah. So that's kind of like VCR. Except I was writing the only thing I don't like about VCR is that a lot of times people think of it in terms of record the results, and then, but I like having more control.
Yeah, I haven't found, I've been in this situation a lot in the last 6 months. I haven't found anything I really like. I haven't used VCR.
Yeah, I mean, I'm working through that. I was fairly happy with that, the way that turned out. There were a couple places where I would only run those tests every couple days against the backend to see if they had changed anything. Yeah, they did.
Speaking of JavaScript and Ruby, since you've experienced both sides of it, I was wondering if you could compare and contrast like testing and using mocks and stuff in JavaScript versus Ruby.
Sure. Testing in JavaScript versus Ruby. I'm at the point now where I actually am fairly happy with my testing setup in JavaScript. Part of that is because I've written my own mocking library, which unfortunately is not open source. It's in-house at the moment. I think that the biggest challenge for me relative to testing has been more of the community angle with JavaScript developers. If you come into a Ruby shop or a Rails shop, because Ruby kind of grew up agile, to use Pat Maddox's term, everybody assumes you should be doing TDD. And if you're not doing TDD, you at least kind of feel guilty about it. And so introducing the concept and getting people doing it is generally, in my experience, not that hard. Coming to front-end UI developers, that's a completely different story. They have no history of doing testing, period, let alone test first. They don't like the idea of even having to do a Selenium test generally because they say, oh, it's different in the different browsers and it's going to break. So most of my struggles with testing have been more along the lines of getting people on the team excited and doing it, as opposed to kind of technologically aimed things. I think part of that is good object-oriented design makes things easy to test, regardless of the language. So the most common, when people are learning to test, they come to me with a common question. How do I test this? They have this set of production code, right? And they're going, okay, I know you want me to write tests for this. How would I test this? I don't know how to test this. And my answer 9 times out of 10 is, okay, well, here's how you have to change the design in order to decouple it and make it testable. And I think if you are decoupling things, it generally ends up being inherently testable. You know, the infrastructure is not as good in JavaScript, but Jasmine's pretty good, and I'm pretty happy with it.
Would you say that there's a difference between services backend design and UI design that leads to the model's testability?
Sure. I mean, I think that the answer to that is kind of similar to the answer to the Rails question in my mind. If you're just decorating a page in JavaScript, you don't need to test it. Write an acceptance test for it, right? If it's something that you're going to do with jQuery, I generally don't feel the need to test that. That's simple. That's, you know, it's just decorating a page. When you start actually building complex logic on the client, where you're starting to feel the need, like if I'm not introducing architecture here, my code is a complete mess, that's the point in time where you're going to want to test. Because you're going to want to be able to refactor that architecture as you're going. And so that's when I generally start reaching for unit tests and so on and so forth. And I think part of the reason why those UI developers, you know, are like, this is stupid, is because, well, they're manipulating a text field and sending a request off to the server, and how much could go wrong? But you know, the stuff that I'm working on now is an application in the client. I guess one other thing, as I'm thinking there, Rails, I think, also doesn't need mocking as much because it is inherently stateless. MVC on the server is different than MVC on the client. Every time you get a request, you're reinstantiating objects and you're rebuilding your state from the ground up on the server. Whereas on the client, you have persistent state. And I think when people start working on the client with complex logic and so on and so forth, all of a sudden design patterns means a lot more because stateful programming is significantly harder than stateless programming. And so testing becomes more important on the client even than on the server.
Were you happy with, this is way off topic maybe, but like Sprout Core's testing framework, what was the answer there for?
So Sprout Core, the Sprout Core was in QUnit,
Okay.
and the framework itself was, apart from the view layer, fairly decently tested. Nobody wrote tests apart from me, pretty much, when we started for applications. I also was not happy with QUnit, and so I wrote a adapter for Jasmine, which is open source, and I think actually has become the default way that people test their Sprout Core applications now.
Oh, okay, I guess I meant the framework building.
What do you mean?
Like, right, the Sprout Core framework
Yes.
that you guys were working on that people would write applications on.
Yes. So the testing for the framework, apart from the view layer,
Yeah.
was pretty good.
Okay.
I mean, there were brittle tests, but at least there were tests for everything. And given that it came out of Apple, that actually is really saying something. So the internal stuff, the tests were really slow, kind of like Rails tests most of the time. But at least they worked, and it was okay to work with.
Greg, in Rails, again, related question. You know, when we write tests, we basically drive the design of code. So for the view test, you know, I can't really drive the design of views by writing a view test first, right? And it's also very difficult to see what the view is going to render to the browser. And it's kind of tricky to write the test first for views. So test first, it kind of like it doesn't give us any benefit actually writing the test first for the view layer at least. So what are your thoughts on this, you know?
So I think the answer there is also it depends. If you have complex view logic, then I generally find it significantly helpful to have view unit tests, because those are going to run infinitely faster than a set of Cucumber acceptance tests. But that being said, I generally would not write tests against the rendered HTML. If there is actual like complex mapping logic, I almost always would put that into a presenter object, or it's not really a presenter, but we call them presenters in Rails. And then I would unit test the presenter object to say that it did the transformation correctly.
So you would still write the test first in that case, or?
For the presenter object,
Presenter
yeah.
object. Okay.
Yeah. Because you're getting like, this data comes in and it's transforming it into something like this. If you don't actually have logic, like a decent amount of logic there, then I just would leave it to the acceptance test. But when I start to, when I feel the pain of, man, I have to run this acceptance test in order to see if I broke something here, and I'm going to wait and make multiple changes because I know that acceptance test run is going to take 30 seconds as opposed to instantaneous, that's the point at which I would start to introduce a presenter, and that's the point at which I would start to do TDD against it on a unit level.
It's occurring to me that there's another metric, rubric right there. I'm working on some code right now that I know that we plan the back end behind this code is going to be completely thrown out and replaced with a new one. Mm-hmm. I'm not actually working on the back end. I'm programming to an existing back end which works, but we're going to replace that. So I'm building a lot of tests whose real purpose is to protect me when the back end turns to mush and turns into something else. Is that, but the back end is code I don't control in this sense. Is this a place where I would use mocking, stubbing, none of the above? What's your
Probably stubbing, I would assume, if you're asking for data. I would probably want to have some form of adapter that did the actual talking to the server that I would do a mock against. So maybe that's a good. So how would you introduce tests to that external layer? If you have a server that you're talking to now, you know that that server is going to change, which means the protocol of communication with the server, I would assume, is going to change.
Right.
The way that I would probably do that is I would introduce an adapter object that all of the objects inside of my domain talk to in the language of the domain, the messages of the domain, that then would map that protocol to the existing server. And then when it came time for that new server to come into existence, the only thing I would have to change is that adapter object. It would still implement the same interface for all of the messages coming in from the domain, but now the protocol with the server has changed. And so I'm going to swap that object for a new object, which is going to talk the language of the new server as opposed to the language of the old server. And in that sense, I would want to isolate those changes from my domain in terms of object-oriented design, not so much making sure that I'm covered with tests. Because my tests, when I change it then, are going to tell me all of the places that I have to change things, but I only want to have to change things in one place.
So Eric Evans calls that as the anti-corruption layer in his book, right? So he has it in the domain-driven design book, has it?
Yeah, the anti-corruption layer that Eric Evans describes is very similar to the ports and adapters architecture. I think that just proves that it actually is an idea that people discover as opposed to creating. Any other questions?
I had a couple of terminology questions. At one point, on one of your slides, you said only mock types that you own, but then you went and just mostly talked about mock implementations, mock roles.
Sure.
What are the types?
So I'm using the historical language there. Probably the better way to say it is only mock objects you own. I think that the type is probably something that has slipped in from Java.
Actually, they make a distinction between value object, like currency,
Sure.
like money. Just use the same value. If it's a value object, just use the regular real object. That's what I understood by reading that book.
So what he's talking about is inside of Agile OO sort of things, there's this idea of a value object. That is, you want to wrap data in a immutable object, right? So for instance, money is a good example of a value object. I'm going to create it with maybe a number of cents, etc., right? But it's a value, not an entity. It doesn't change over time. It's not representing a process, it's representing a value. And you definitely wouldn't want to mock a value since you can just use the real thing. But the point I was trying to make there isn't quite that one. I meant more so like in Rails, right? Don't mock an active record object. Don't mock a controller object. Don't mock anything that you did not create the API for. And so I meant that more in terms of an object. I think that the term type comes from Java because they were describing it in Java. So like when you create a class in Java, you're making a new type. But I think object would be a better way to put it.
Greg, along the same lines, if Ruby has string, integer, it has value object built in, string and stuff, I don't really want to mark that string object. I want to just use the string object.
Yes.
So if I'm using a Rails framework, I would say API is stable enough, so I don't really have to worry about, my code breaking. I can just use a real active record object, right? Is my understanding right? Because if it's a built-in Ruby types, I just use them in my tests.
So generally the way in Rails, I wouldn't mock an act. So I think an active record object is better thought of as a persistence layer as opposed to a domain object. The purpose of active record is to map the things to the database. I wouldn't mock out the database. I would consider anything that actually is touching the database as an integration test. And so I would want to use the real database, not like mock the things that I can type to. Which is why I think that they make the distinction, you only mock types you own, and they mean only mock objects that you create the interface for. So that you're getting design feedback and you're actually doing design as opposed to just talking to an external interface. If you want to test that, say, like the persistence layer works, run it against a real database. Break those into a separate folder so that you don't have to run those at the same time as your unit tests, because those are going to be orders of magnitude slower than your unit tests. But use the real thing, don't use... If you didn't create it, use the real thing. So we should probably wrap up with that. I'll be here. I'm willing to answer questions. Also, like, if you want to try doing some of this, you run into anything, please feel free to shoot me an email, gmoeck@gmail.com. I probably have gotten 50 or 60 emails from the RubyConf talk, and I've tried to reply to everyone. I generally learn a lot from talking with people, and so if you're going to try it, I would encourage you, email me and talk about whatever you run into, and that way we can kind of learn together.